Hello dear fans. What is absolute pressure? Pressure is an important physical quantity that characterizes the behavior of liquid and gaseous substances. Absolute pressure is the pressure measured relative to a temperature equal to absolute zero. This pressure creates ideal gas on the walls of the vessel. General concepts. From the point of view of science, the absolute pressure is the ratio of the pressure in the system to the pressure in the vacuum. The most common expression for absolute pressure is the sum of the system sensor and the atmospheric pressure. The expression takes the form: absolute pressure equals gauge pressure plus atmospheric pressure. Atmospheric pressure is defined as the pressure of the surrounding air on the Earth's surface. This value is not a fixed or constant value and may vary with temperature, altitude, and humidity. Gauge pressure is the pressure in the system that has been measured with a measuring device. These devices, or sensors, can be classified according to their design features. The most common types are resilient sensors, liquid column sensors, and electrical devices. If the sensor does not take into account the atmospheric pressure in its readings, then the absolute pressure is calculated manually. Measurement units and practical application. In practice, absolute and gauge pressure are not the same system specification. Therefore, each of them has its own designation. The most common technique is to add indexes. After the letter denoting absolute pressure, put the index A, and after the gauge M. Such designations are most often used in engineering calculations. When performing them, it is necessary to use the correct pressure designation in order to avoid errors. The difference between absolute and gauge pressure is much more noticeable when atmospheric pressure is of the same order of magnitude as gauge pressure. Neglecting the atmospheric component of absolute pressure in calculations also leads to serious design errors. This can be demonstrated by examining a closed cylinder with an ideal gas at a temperature of 25 degrees Celsius and a volume of 1 cubic meter. If the pressure gauge on the cylinder shows a pressure of 100 kilopascals, and the atmospheric pressure is not taken into account, then the estimated number of moles of gas in the cylinder is approximately 40:34. When the pressure of the atmosphere is also 100 kilopascals, then the absolute pressure is actually 200 kilopascals, and the correct number of moles of gas would be 80.68. The actual number of moles of gas will be twice the original calculation. This example shows the importance of using the correct pressure calculation algorithm. Thanks for watching.